Find the critical numbers of h of x is the fifth root of x times 2x plus 8 squared. All right, so we have a root, but it's an odd root times a polynomial. There's no worries from the polynomial. The worry is with the root function that there could be some domain issues. But since it's an odd root, just the fifth root of x, there's no domain restrictions. So for this function, the domain is all reals. Let's calculate the derivative. Let me think of that fifth root of x. Remember, that's x to the 1/5 power by 2x plus 8 squared. So remember to think of it like that when calculating the derivatives. So I'm going to have to use a product rule and a chain rule. So then h prime of x would then be 1/5 x to the negative 4/5 times 2x plus 8 squared plus x to the 1/5 times 2 times 2x plus 8 to the first times 2 from the chain rule. So there's the derivative, but for calculating the critical numbers, I'm going to want to work with this sum. So let's do some factoring here. And so again, remember, here's one term, here's a second term, and let's think about what we see in common. I see x in common. X is a common factor here, and we choose the lesser exponent. So between x to the negative 4/5 and x to the 1/5, negative 4/5 is lesser. So I will factor out x to the negative 4/5. I see 2x plus 8 is a common factor. I will factor out again the lesser exponent. 2x plus 8 to the first power. I'm writing the 1 on purpose there. Okay, so then what's left over? From the first term, I have a factor of 1/5. And I have, let's see, I factored out the x to the negative 4/5, and I factored out a 2x plus 8 to the first, so I need a factor of 2x plus 8. Plus. All right, now let's see. For the second term, I factored out x to the negative 4/5. What would I have to multiply x to the negative 4/5 by to get x to the 1/5? So negative 4/5, if we think about rules for exponents, negative 4/5 plus 5/5 is 1/5, isn't it? So I have here an x to the 5/5, which is really just x to the first. But I'm writing it like that temporarily so you understand how I got to understand what's going on in the background. And what else is left? I have a 2 times 2, that's a 4, and I factored out the 2x plus 8. So here, remember what I just said. This x, that's x to the first power there. That's a 1. Right? That's an x to the first power. So then what do we have? We have x to the negative 4/5. We have a 2x plus 8. Then we have, in the brackets, we have a 2/5 x plus 8/5 plus 4x. So that's an x to the negative 4/5 by a 2x plus 8. And let's see, 4x plus 2/5 x, that's 20/5 plus 2, that's 22/5 x plus 8x, plus 8/5. Now, let's think about this. This x to the negative 4/5, if I really wanted to, I could write that in the denominator. Right? That's a 2x plus 8 times a 22/5 x plus 8/5 over x to the 4/5, isn't it? All right, so now where is the derivative? Equal to 0. Where is h prime of x equal to 0? Well, if the derivative is equal to 0, then the numerator would equal 0. So 2x plus 8 equals 0. That implies then that x equals negative 4. 22 fifths x plus 8 fifths equals 0. Multiply by 5. 22x plus 8 equals 0. Subtract 8, divide by 22. X is negative 8 over 22. That's negative 4/11. Where is h prime of x undefined? It would be undefined if the denominator was equal to 0, and that happens if x to the 4/5 is 0, which implies that x is 0. Now, the domain of the function, remember, was all real numbers. But when x equals 0, the derivative is not defined. The derivative is undefined. So 0 is a critical number. So the critical numbers of h of x are x equals negative 4, negative 4/11, and 0.